Today on Engine Power, barely legal Mustang gets track ready with a 6-speed Magnum gearbox, 10-puck ceramic clutch, and 6-point bolt-in cage.
By now, you know the car and its purpose. In recent weeks, we've been transforming this Fox body from a road heat to a competition-worthy corner carver with suspension from Maximum Motorsports, and trading its sad 4-cylinder for this Ford Racing Aluminator crate engine we made 451 horsepower with on our dyno. Then stuffed it into its new home for mock-up.
Ha, we're clear.
In short, we went from this to this. A great start to a roadworthy, track-ready, barely legal Mustang. Since then, we removed the Aluminator to clean up the engine bay before adding some Duplicolor self-etching primer and a coat of paint.
Today, we plan on finishing it all the way to the cockpit.
From a roll cage to our customized stock seats and a long list of performance parts. We started with Maximum stainless pre-bent rear brake lines that come with all the correct fittings to attach them to the braided flex lines. Now up front, no more power brakes. We're going manual with help from this billet firewall mount from Maximum and extra hands from a neighbor. Now due to the width of the engine, we need to use a master with outlets on the strut tower side. This one is from a Ford Ranger. With our new lines attached, the brake lines are finished.
The factory fuel tank just won't cut it for our Fox's purpose. Now hard cornering at high speeds will cause the fuel to run away from the pump's pickup area. So we got this one from Glenn's Performance that started back in 2004 due to the lack of high performance fuel tanks and systems for Mustangs that were affordable. The 03-04 COBRA tank like this was the best one ever built for a Mustang, but it did have some limitations. So Glenn's went inside and improved the sump size by enlarging it to hold more fuel in the center. The baffling was also enlarged to control the fuel in the sump. Now the feed tube diameter is also larger for more fuel volume to the supply line.
This tank mounts in 79 through 2004 Mustangs and accepts the factory filler neck. It can be ordered with internal or external pumps and will support up to 1,700 horsepower. The factory straps secure it in place. Now this one is set up for an external pump with a -8 feed and a -10 return from the regulator. Using this template, we can mark the mounting hole locations for our fuel pump. It's a Holley Dominator inline billet pump that will support 1,800 horsepower in an EFI application. It's a twin pump design, allowing the second pump to activate when needed in a boosted or nitrous setup. A Holley pre-filter will be installed directly to the pump. Now make sure to use 100 micron here or drivability and pump issues can arise. The Earl's lines are 2 colors for easy identification. Now they will route so they are above the lowest point of the chassis. Securing them are 5/8" Earl's cushion clamps. They will follow the subframe connector on the passenger side and pass through the inner fender area into the engine bay. Here's a cool new tool to assemble push lock hose and fittings the easy way. It's the Easy On hose press from Cool Tools. The line goes in the rear one. A fitting is placed in the front jaw. Now using a drill or impact, turn the Acme screw to install the line onto the fitting. The return will attach to the bottom of our billet Holley regulator, and the feed line from the pump will attach to the inlet port. Down. Now the engine goes in.
We're good.
For the last time. An American Powertrain Street Slayer 10-puck powdered ceramic clutch. Now it will handle 845 foot-pounds of torque.
Their pressure plate has a high tip and release point, which means these fingers don't have to move very far for the clutch to engage or disengage.
This also creates an effortless pedal force.
To complement the 4:10 gear ratio in our 8.8 rear end, we're using a Tremec MAGNUM 6-speed transmission prepped by American Powertrain. Now the 6th gear is going to give us an awesome overdrive for lower RPMs at highway speeds. Now they installed one of their White Lightning fully adjustable shifters, and to control the clutch, we're going to use one of their Hydromax hydraulic release bearings.
With a complete kit like this, no modifications were needed to the car.
Up next, the cooling system and cockpit become race ready.
We're back, but my extra set of hands is not. He had to get back to his everyday workload, but I'm not continuing solo. Remember this guy when we dynoed the flathead? Oh! Well, he impressed us with his knowledge and dove right in and helped out so much. This round, he's here to stay. And these long tube headers he's banging on are from Summit Racing. Now they're BBKs that are ceramic coated and designed to fit the Fox-body with a Maximum Motorsports K-member and a Coyote or Aluminator engine. Now they have 1 3/4 primaries that lead all the way back down into a 3-inch collector.
There you go.
With the factory Ford gasket in place, we'll use the old hardware to seal them up.
Oh yeah, that is success right there.
Now to keep our barely legal status, we chose an X-pipe with high flow cats to pass emissions in our area. It's 3 inches in diameter. From there, 3-inch Magnaflow pipe will tie into a race series 5x8 oval muffler. At just 12 inches in length, it fits in super tight spots. A hand-cut turndown will finish the exhaust off. Moving on to the cooling system, this 3-core aluminum radiator from Summit Racing is going to keep our Aluminator's temp in check even during those hard laps out on the track.
D'Oreilly sent us this universal dual high output fan system with an aluminum shroud. Combined, they produce 3,750 CFM. It's not designed to fit any specific radiator, so they give you these brackets to help you out. Now at this point, you're on your own. But it's really not that hard. They have some slotted holes in the shroud itself to line things up, and we'll punch some holes in the radiator to fasten it down. First, I'll mark the holes to be drilled in the radiator's flange. Then, using an 1/8-inch can-cut bit as a pilot, I'll get the 4 holes drilled in the bottom. Then enlarge them to the final 1/4-inch diameter. The brackets attach to the shroud first. Then they can be aligned to the radiator and attached with new hardware. And with the same steps being followed for the top side, this package is ready to drop in. It rests in the original location and is held in with the factory brackets. And the hose goes right on with no modifications.
Cleaning up the engine bay on a Fox body can be a time-consuming task. Welding up all these holes plus the body work is going to add a few days to your project time. So here's the easiest and most affordable way to take care of it. It's inner fender well panels from Scott Rod Fabrications. Now they're made of lightweight aluminum and formed around a car every time for a near-perfect fit. Now we'll go ahead and install this driver's side first. They slip into place just in front of the strut towers. Now once flush, we can drill an 1/8-inch hole and secure the panel with a rivet. This step is repeated several times until the panel is locked down and vibration free.
So we just got to go 1 1/8 inch.
The other side needs a small trim towards the front due to a bracket we welded on the car. Now once in place, it gets fastened the same way. To keep them scratch free, we're leaving the protective film on until the car is finished. Now we can mount the Ford Racing ECM in its new home. It rests on 2 90-degree brackets that we welded to the subframe rail. This is the same general area Ford puts it in the new Mustangs. All right, before we run any harnesses through the firewall into the driver's compartment, it's time to move on to the next part of this build. Now, safety needs to be #1 on any list you've got. For that, we're using one of Maximum Motorsports' 6-point roll bars. It's constructed of 1 3/4 134 wall DOM tubing, which is much stronger than your standard 120 wall seam tube. It has low slung door bars for easy entry and exits and a removable harness bar. The first piece to go in is the main hoop. Now the goal, no broken glass. Now take your time and this whole process will be easy to deal with.
Very nice.
The rear braces go on next. They keep the main hoop upright in case of an accident and add lots of rigidity to the back of the car.
Oh yeah.
Am I seeing that right?
Isn't that awesome?
That thing fits perfect against fender well.
With them lined up to the wheel well, we can tighten the through bolts. Now we can drill holes through the floor and remove the assembly from the car. This allows you to weld them in place without hurting the interior or glass from spatter. Once cooled off, we can add some VHT roll bar and chassis paint. 1 light coat followed by 2 heavier coats will give us plenty of cover. With it dry, this section of the cage goes in for the final time. Now we can mix our lizard skin car ceramic insulation. It's water-based and composed of high-grade acrylic binders and ceramic insulation particles that create a thermal barrier. You can use it on any type of car or truck where heat may be an issue. Now we're spraying our prime floor pans of the Mustang to keep us cooler on those hot track days. There's hardly any overspray, and with a good prep, it will stay in place very well. Drying time is right at 24 hours for a full cure, and it will be paintable.
Coming up, we finish off the track-ready interior with a little comfort for the street.
With the lizard skin desert dry, now it's time to tie the cage into the chassis. Now Maximum sends reinforcement plates that sandwich the floor pan. They're bolted in and add tons of strength, so from here, you can return your buddy's welder.
Just like in the engine bay, we're going to give this car's interior a visual cleanup as well, using more of Scott Rod Fabrication's lightweight aluminum panels. Now this is their rear seat delete kit for a Fox body, and it satisfies most sanctioning bodies' requirements for a barrier in between the driver's compartment and the trunk. With the center line of the seat marked, the first panel to go in is the upper passenger side, followed by the upper driver's side to check fitment from the center line. Now we can drill one hole and attach the passenger side with a screw just to hold it in place. The passenger lower panel goes in to establish the front to rear positioning of the rear panel. Repeat this on the opposite side, and with the panels aligned, rivet them together. Position the wheel well cover and check fitment. Trimming here may be necessary. A hole saw that matches the bar's size is used to mark the section to be cut. I'll use tin snips to cut it into ribbons so it doesn't distort the panel when I cut them out. I'll finish it off with a file and then recheck it for fit. And I'll claim I got it right the first time. Same story for the other side. It's a classy and affordable way to dress up the interior in a few hours.
We decided to go with the low-slung door bar option, so getting in and out of the car is super easy. Now they tie into the main hoop and the front floor pan area. Reinforcement plates are used at every point of the cage to sandwich the body. This increases the shear point by having a larger footprint and adds lots of strength to the cage's integrity. 3/8 hardware is used, and notice how the floor is squeezed between the plates as they're tightened. The final task? Drill through the door bars and place the supplied bolts in to secure them to the hoop.
To keep on the safety topic, we're using Sparco's 4-point race harnesses. Now these things use a factory type latch and the belts are 2 inches wide. They come with a threaded eyelet that, lucky for us, is the same thread as the Fox-body's factory seatbelt hardware.
And attached to them are quick connect latches on both sides. Up top, the shoulder belts will lay over the harness bar for now. They'll wrap around our factory seats. That's right, these started as the factory red seats in this car. Now TMI supplied their R500 upholstery kit that includes 2 seat foams, black vinyl seat covers with Unisuede inserts, and are available with several stitching and color combinations. They also have tons of hip and side bolstering to keep us in place while cornering. The car still has a little ways to go: wiring, custom gauges, and a full color change. Now there's no sense on building it if we're not going to play with it. It's going to the road course to get beat on, and all that's going to happen soon. For now, we need to take a look at a series of tests you don't want to miss.
You've heard it before, the dyno doesn't lie. See how Diamond Fire technology can make a difference.
The aftermarket has always relied on new technologies to improve performance in products that we use every day, whether it be for air, fuel, or spark. Well, you know how we always love a good shootout? We decided to see how E3's premium spark plugs match up to the leading competitors. To see which plug had the most powerful spark, we did a side-by-side test with this tester box. Visually, the winner is E3. Now here's an E3 on the left with the top competitor on the right. E3 uses something called Diamond Fire technology, which involves an edge-to-edge electrode design that optimizes the spark path, with a faster and larger flame thrust into the combustion chamber. But the proof's really in the engine. We installed and will test the competitor's plugs first on this 383 stroker, using 93 octane fuel. With all parameters equal, we'll do 3 pulls with each set of plugs from 25 to 6,000 RPM. After letting the engine cool, we remove the plugs and install the E3s. We'll test for horsepower and fuel usage, which the computer identifies as brake-specific fuel consumption. Technically, it's the amount of fuel it takes in pounds to make 1 horsepower. Here's what we found. The first set of plugs made 407 horsepower on average with a brake-specific fuel consumption of 0.626. The E3 spark plugs made an average of 412.5 horsepower and the brake-specific fuel consumption 0.606. Needless to say, both premium plug brands outperform the standard plugs, but the E3s made more horsepower using slightly less fuel, the best of both worlds. But what about emissions? The theory is E3's greater combustion lessens the amount of carbon monoxide and hydrocarbons that escape into the air we breathe. So we invited the guys from Sensors Inc. to take some exhaust measurements, this time on our fuel-injected LS Mule.
We have a lot of confidence in what our product can do and the combustion efficiencies that it produces. And with the new SimTech system that is now available, we feel like it's one more effort to go improve the technology and to show the results and that better combustion.
Greater combustion on the E3s shows a 2 to 3% decrease in CO2 emissions. That's your fuel economy. The NOx readings equate to air pollution, specifically nitric oxide and nitrogen dioxide, which showed a 43.3% reduction. Pretty significant. Those tests were conclusive on 93 octane, but what about newer, cooler burning fuels like ethanol? For that, we took a trip to a Midwest university that specializes in automotive research. Graduate students at Michigan Tech's Advanced Power System Research Center work toward developing clean, efficient, and sustainable power system technologies. Which is why companies like E3 turn to this state-of-the-art facility for data on how their parts perform on cooler burning ethanol. It's equipped with fuel sources, laser diagnostics, and high-speed cameras that are housed in a stainless steel optical combustion vessel, all necessary to film spark plug burn cycles in real time at 5,000 psi. This video illustrates the faster flame kernel of the Diamond Fire plug compared to a stock J-wire plug.
So the Diamond Fire has, a better initial flame kernel development and stronger flame propagation, and it's more turbulent, which can help with emissions, and also your fuel efficiency.
Technology companies like E3 will continue to work with research scientists to validate their performance benefits versus conventional parts. In additional dyno testing, the faster burn rate of the Diamond Fire plug also produced more torque and more power than standard plugs using E85.
I think, as engines change, as fuel changes, and other parts of the car change, we need to be developing as well. Obviously, we think we have the most advanced spark plug on the market today, but we're committed to making sure we stay in that position, and that's, again, one of the reasons why we're here doing all this testing.
At some point, we've all had a rear view mirror come off at the worst possible time. The good news is Loctite has an easy fix for putting it back up where it belongs. Their rear view mirror adhesive is a permanent fix to an age-old problem, and it's approved by GM, Ford, and Chrysler for doing the job correctly. Following the instructions to a T will ensure a tight bond, and you'll be back in business in no time at all. And it's available from your local parts store for around $3.
If you're a fan of quality parts made in the USA and have a 1955 through 1986 small block Chevrolet, this EDELBROCK RPM air gap intake manifold is the right choice for you. Now, it gets its name from the open airspace between the bottom of the runners and the floor of the intake manifold. This allows a cooler, denser air charge to enter the engine, which is a huge ingredient for the horsepower recipe. Now, you can find one of these intakes anywhere performance parts are sold for under $245. That's it for this week. We'll see you next time.